Now we're taking a look at two-sided limits, meaning we will use the concept of one-sided limits to evaluate two-sided limits. So let's go through the definition here. If the limit as x approaches a from the left of f of x and the limit as x approaches a from the right of f of x both exist and are the same value or number L, which remember is your y, then the limit as x approaches a of f of x exists and is equal to that same value L. Okay, so this is our definition. So if either the one-sided limit does not exist, meaning you're coming from the left or the right, or they both exist but are different values, meaning when you approach from the left you get 5 and from the right you get -2, then the limit as x approaches a overall of f of x does not exist. And we will use the abbreviation does not exist, DNE. Okay? So if the limit as x approaches a of f of x is equal to L, then what that means is both one-sided limits exist and they are both equal to the same value L. What we're going to do is jump to the top of page 3 and take a look at this example. So we're only looking at this graph, and we have the limit as x approaches -5 of f of x. Okay, so since we're evaluating the overall limit, we have to look at what's happening from the left and from the right. So we're going to -5 here, okay, and we want to evaluate. So we're coming from the left. So here's -5, so I'm going to go up this way and across this way. So when I approach from the left and from the right, they're both equal to the same value of 4. Okay, so let me jump here to B. The limit as x approaches 2 of f of x. So I need to look what is happening as x approaches 2 here and as x approaches 2 here. So you notice that you have a point and an open circle. Because we're evaluating the limit, we do not care about this point. We care about the behavior of the function, meaning what is happening at that graph. It doesn't matter that this is an open circle. When I approach from the right, my value is 3. When I approach from the left, my value is 3. That means as we get sufficiently close to where x is equal to 2, my y value is 3. So in example 3, let's just look at this graph really quick. We're going to look at C. The limit as x approaches 0. Okay, so you notice here, since this is the overall limit, I have to take a look at the limit as x approaches 0 from the left, which is 1, and from the right, here, this is equal to -2. So because my left and right-handed limits are not equal, this does not exist. Okay, so what we want to take a look at right here in example 5 is how we would evaluate this in the calculator. So first of all, what you need to make sure of is that all trig in calculus will be in Radian mode. Okay, and typically what we want to look at is being able to evaluate the limit by using direct substitution. But as soon as you plug in 0 to the denominator, you already know that this function is undefined. Even if I did do this and I plugged in, the sign of 0 is 0 over 0, so this is indeterminate. So I can't even do this, so I would get an error message here. So what I need to do is evaluate as I approach from the left and from the right. So what we're going to do is go into the calculator and put this function in. So I have the sine of x over x. So now what I want to do is go in and use the table. And if you go in right now, it automatically puts in values. And you notice there are specific values that we want you to use here. Okay, so what we want to do is go into second window and change my independent to ask. I want specific values. So now I go into the table and this is completely blank, and that's totally fine. What I need to do is actually plug in these values. So I'm going to type in -0.1. These are all coming from the table. I press enter. -0.01, -0.2, 0.001. So when I do that, and actually when I go up here and look at this, you can actually see the true value because it rounded. When I plug this in, I get 0.99833, 0.99998, and then this one was 0.99999. Now I want to approach from the other side, so when I type this in, right here, I've got 0.001, 0.01, and 0.1. So then I go back up here, and I can see this is the same value as this one. So this is 0.99999, 0.9998, and 0.99833. So what we have to do is draw a conclusion. As I approach 0 from both sides, what is my value for y getting closer and closer to? In this case, the answer is 1. So the limit as x approaches 0 of the sine of x over x is 1. This is the behavior of the function. Okay, with that said, we would need to take a look at the limit, meaning a graph. So what I'm going to do is take a look at a couple of these graphs here, or these limits here, and see what happens. So what we want to do is take a look at the left-handed limit, right-handed limit, and then what's going to happen overall. So here, if I evaluate the limit as x approaches -2 from the left, we already figured out from the previous example that this was equal to 1. The limit as x approaches -2 from the right is 0. So you notice that these two limits are not equal to each other, therefore the limit overall does not exist. Okay? So if we take a look at that, the other thing that I want to take a look at is, what if I wanted to evaluate f of -2? So we know that the limit from the left exists, the limit from the right exists. The limit overall as x approaches -2 does not exist because the left and right-handed limits are not the same. F of -2 means I'm looking at the point, meaning what is the function evaluated at -2? Here, it's like I have a choice, but I really don't. What I'm looking at is the solid point. Therefore, this answer is 1.